Hi everyone, welcome to the program Copra Application and Data Visualization. In this unit, we will discuss about the linguistics and NLP. Do you remember NLP? Now you know that natural language processing is a part of computer science and artificial intelligence. Those deal with human language. Actually, in our daily life, the language we use, most of them are unstructured, and just some of them are structured. We try to teach machine to know and to learn our human language from those unstructured parts to structure analysis. From those big data, now we use that in our mobile phone, our pad, and our chat GPT, right? As you know that, linguistics and NLP, they have close relationship. Natural language processing is the study of computational techniques that help computers to understand and communicate in human language. For example, those words, those sentences, do you understand them? For computers, they don't really get that. Each word or each token, they show people the meaning of individual words. But when we put them together, we can comprehend that easily. But for computers, actually, they should study that. This is what you have learned that before in the linguistics. For example, pragmatics, how do we use that in different contexts? For example, semantics, how do we comprehend that? For example, word order, word analysis, speech, sentence pattern, syntax. All right? To understand NLP, to understand linguistics. From the corpus, the collection of language data, you know those are files in corpus, the collection of language data. The language are for you to know about the different sentences, and from different sentences, you check about the different words. And how do you analyze them? Well, how do you analyze the context? You analyze the text. We should learn about some words. We don't need to analyze that. Some for grammatical functions, some for parts of speech. Those are the terms you have studied in linguistics. All right, if you get these ideas, you know the application of NLP. We use the NLP to check our spelling. We use NLP to check the information, to find out some keywords, or even for advertisement matching. In this program, you will learn about the segment analysis. For the speech recognition, chatbot, and machine translation, I think you had practiced that before, and especially for machine translation, now we use ChatGPT a lot, and they can help us to deal with those translations. Again, for NLP, you know there are two subfields. One is from unstructured natural language understanding to the natural language generation. For example, please put X and groups into the box. Add words, right? Add tokens. Then from these add tokens, well, you understand you should do an action, put something into a box, right? Then for natural language generation, you should give these 8 tokens to machine. Then box. From the box, you have those 2 items, all right? The sentence, please put X and the grapes into the box. The box, that is a stop word. All right, if you learn about this, remember these terms. Tokenization, to find out how many words, we use that into a sentence. And the stemming, lemmatization, these two are for you to check about the words. All right, so change, changing, changes, chant, changer. Those words, actually we have one stem, C-H-A-N-G, right? With ing, with es, with ed, with er, okay? Then for change, changing, changes, changer, changer. Then lemmatization, we find out the root of the word, that's change, right? So you get ideas about that. Just like good, better, best. 3 different forms of the word good. Then that's a lemmatization, all right? But we cannot find the same stem for the 3 words. Or another one is for you to see studying, studies, and study. Different parts of speech, right? Then from that lemmatization, we have study. All right, so from here, you can see this is about the syntax, the analysis of sentences, the analysis of words, okay? So POS, post-text, we put all these parts of speech, put all these words into, well, analysis. And name entity recognition, you can see that we try to figure out each word with different meaning. All right, for example, I go to the riverbank and I deposit my money into bank. I deposit my money into the bank. 2 banks, actually, they are with different meaning if you understand English. But for machine, well, you should teach them. This is about name entity recognition. You should figure out the meaning, the semantics. All right, then the last one is chunking. We put a group of words together to have the meaning. All right, so here are for you to get some ideas. And actually, this is a review of your grammar. Okay, now you know those terms, you get those ideas. Here is the video to show you some information about, well, what we use NLP to machine translation, for semantic analysis, for span dictation, and for chatbot, right? From that, you get the idea about the tokenization for stemming and the lemmatization. Then POS taggings, and this is actually the name entity recognition. So from NLP, you learn about the NLU and the NLG. All right, now let's view this video. You will get more ideas about the NLP. Please check those terms you don't know or you would like to know more. Then you can answer some questions. What is NLP? What is NLU? What is NLG?
What is natural language processing? Well, you're doing it right now. You're listening to the words and the sentences that I'm forming, and you are forming some sort of comprehension from it. And when we ask a computer to do that, that is NLP, or natural language processing. My name is Martin Keane. I'm a master inventor at IBM, and I've utilized NLP in a good number of my invention disclosures. NLP really has a really high utility value in all sorts of AI applications. Now, NLP starts with something called unstructured text. What is that? Well, that's just what you and I say. That's how we speak. So, for example, some unstructured text is add eggs and milk to my shopping list. Now, you and I understand exactly what that means, but it is unstructured, at least to a computer. So what we need to do is to have a structured representation of that same information that a computer can process. Now that might look something a bit more like this, where we have a shopping list element, and then it has sub-elements within it, like an item for eggs, and an item for milk. That is an example of something that is structured. Now, the job of natural language processing is to translate between these two things. So NLP sits right in the middle here, translating between unstructured and structured data. And when we go from unstructured here to structured this way, that's called NLU, or Natural Language Understanding. And when we go this way, from structured to unstructured, that's called Natural Language Generation, or NLG. We're going to focus today primarily on going from unstructured to structured in natural language processing. Now, let's think of some use cases where NLP might be quite handy. First of all, we've got machine translation. Now, when we translate from one language to another, we need to understand the context of that sentence. It's not just a case of taking each individual word from, say, English and then translating it into another language. We need to understand the overall structure and context of what's being said. And my favorite example of this going horribly wrong is if you take the phrase, the spirit is willing, but the flesh is weak, and you translate that from English to Russian, and then you translate that Russian translation back into English, you're going to go from the spirit is willing, but the flesh is weak, to something a bit more like the vodka is good, but the meat is rotten, which is really not the intended context of that sentence whatsoever. So NLP can help with situations like that. Now, the second kind of use case that I like to mention relates to virtual assistants and also to things like chatbots. Now, a virtual assistant, that's something like Siri or Alexa on your phone that is taking human utterances and deriving a command to execute based upon that. And a chatbot is something similar except in written language, and that's taking written language and then using it to traverse a decision tree in order to take an action. NLP is very helpful there. Another use case is for sentiment analysis. Now, this is taking some text, perhaps an email message or a product review, and trying to derive the sentiment that is expressed within it. So, for example, is this product review a positive sentiment or a negative sentiment? Is it written as a serious statement, or is it being sarcastic? We can use NLP to tell us. And then finally, another good example is spam detection. So this is a case of looking at a given email message and trying to derive, is this a real email message or is it spam? And we can look for pointers within the content of the message. So things like overused words or poor grammar or an inappropriate claim of urgency can all indicate that this is actually perhaps spam. So those are some of the things that NLP can provide, but how does it work? Well, the thing with NLP is it's not like one algorithm. It's actually more like a bag of tools, and you can apply these bag of tools to be able to resolve some of these use cases. Now, the input to NLP is some unstructured text, so either some written text or spoken text that has been converted to written text through a speech-to-text algorithm. Once we've got that, the first stage of NLP is called tokenization. This is about taking a string and breaking it down into chunks. So if we consider the unstructured text we've got here, add eggs and milk to my shopping list, that's 8 words, that can be 8 tokens. And from here on in, we are going to work one token at a time as we traverse through this. Now, the first stage, once we've got things down into tokens that we can perform, is called stemming. And this is all about deriving the word stem for a given token. So for example, running, runs, and ran, the word stem for all 3 of those is run. We're just kind of removing the prefix and the suffixes and normalizing the tense, and we're getting to the word stem. But stemming doesn't work well for every token. For example, universal and university Well, they don't really stem down to universe. For situations like that, there is another tool that we have available, and that is called lemmatization. And lemmatization takes a given token and learns its meaning through a dictionary definition, and from there it can derive its root or its lem. So take better, for example. Better is derived from good, so the root or the lem of better is good. The stem of better would be bet. So you can see that it is significant whether we use stemming or we use lemmatization for a given token. Now, next thing we can do is we can do a process called part of speech tagging. And what this is doing is, for a given token, it's looking where that token is used within the context of a sentence. So take the word make, for example. If I say, I'm going to make dinner, make is a verb. But if I ask you what make is your laptop, well, make is now a noun. So where that token is used in a sentence matters. Part of speech tagging can help us derive that context. And then finally, another stage is named entity recognition. And what this is asking is, for a given token, is there an entity associated with it? So, for example, a token of Arizona has an entity of a US state, whereas a token of Ralph has an entity of a person's name. And these are some of the tools that we can apply in this big bag of tools that we have for NLP in order to get from this unstructured human speech through to something structured that a computer can understand. And once we've done that, then we can apply that structured data to all sorts of AI applications. Now, there's obviously a lot more to it than this, and I've included some links in the description if you'd like to know more. But hopefully this made some sense, and that you were able to process some of the natural language that I've shared today. Thanks for watching.
After watching this video, I hope you get complete ideas about NLP. From the NLP to NLTK, we will study Python. In our next topic, we will talk about the Python language and how to analyze human language. So see you in the next unit. Bye-bye.